Hello everyone, welcome back to my channel. Hope you all are doing good. Now we are going to understand how to implement linear algebraic concepts through NumPy. So let us start without delay. Now let us understand how to implement all linear algebraic operations over NumPy matrix or NumPy arrays, right? Now let us see. So guys, whenever we are saying that it's a two-dimensional array, so all arrays, how we are talking, like I've already mentioned, we are talking about a matrix here, correct? So this is one matrix I have taken, and that matrix is a two-dimensional array. And how we are presenting? We are presenting like 1, 2, 3, 4, right? This is my matrix. This is one matrix, right? Now let us see. And this is one vector. Vector, again I told you guys, it's a single dimension. When I'm talking about single dimension, that is your vector. When I'm talking about multiple dimension, that means multiple vectors are getting converted into a matrix. I have already told you in our mathematics videos, right? Now let us see. The first operation what we are trying to do, and these are our basic operations, like we are adding, subtracting, then we are multiplying with matrix. So let us see the first example of matrix addition. What I did, I have taken a first matrix. This is another matrix. Now I want to add these two matrices. And now let us see what is the output here. See, this is the output we are getting. So how is adding? Let's see that example. 1, 2, 5, 6. This is one matrix. And this is another matrix. 7, 8, 9, 10, 11, 12. How addition is happening, guys? Basic mathematics. 1 plus 7, 2 plus 8, 3 plus 9, 4 plus 10, 5 plus 11, 6 plus 12. So what is the final matrix I am going to get, guys? I am going to get 8, 10, 12, 14, 16 and 8. This is my final matrix. And this is how your addition happens, right? Something like that I got it. Okay. Now let us see the next example. So after addition, what is the next operation we have, guys? We have matrix division or matrix subtraction. My bad. Matrix subtraction. So how we are doing? So guys, here I have missed one point. So the same thing, right? We have just added like this. So the same thing can be achieved by using np.add. So NumPy has that method, np.add. So it is just going to, you just need to pass. It's a function again, right? Again, I have already told you how function is getting called. You need to pass these two. It is expecting these two parameters. So you need to pass these two parameters and it is going to add those two and it is going to give. And like I said, right, what is the first thing I told you? In list, these things are not possible, right? Is it possible? Are we getting the correct output? We are not. When we are adding consider two one-dimensional list, what we are getting, it is just simply, duplicating the values repeatedly. If I am adding 2, then it is just repeating those values, which is incorrect, right? We need addition, means it needs to be properly add those elements. So here we are able to achieve it. So here we can see. If we'll again print the output, right, it is going to give me the same output. See, right? Now let us see another example. When we're talking about difference, right, again, here, just need to get the difference. What is the difference going to come here, guys? Just instead of plus, just give a minus here. What it is going to do? 1 minus 7, 2 minus 8, 3 minus 9, 4 minus 10, 5 minus 11, 6 minus 12. So, my matrix is going to be like minus 6, minus 6, minus 6, minus 6, all are minus 6, minus 6, and it's a good number, right? So, here, another example let me take. So, similarly, what it did, 5, what is the, okay, 5. It is something like 5, 8, 7, 10. 5, 8, 7, 10. Which is my first matrix. Minus 2, 4, 3, 6. 2, 4, 3, 6. Another matrix. Let us see. 5 minus 2. 8 minus 4. 7 minus 3. 10 minus 6. Right? What is the output I am going to get here? 3, 4, 4, 4. And the same thing we got the output over there, right? Let us see. Right? See. And like I already said, NumPy has a built-in methods. Like we added, similarly we can use subtract. Right? This is again a function. So you can either do like this or you can do like this. These are the two methods I have told you. And guys, you will not get these kind of explanations in any of the other platforms. Trust me. Then we have dot product, cross product, right? And dot product, cross product are applicable on what? On vectors, right? So let us see. So if you'll see on top, I had taken a vector, right? 5, 6. This is my vector. Now I want to get the dot product of those two. And this is how the output I am getting. Sorry, I need to run that. Yeah. Done. Now let us see. We should not be getting an error. I got 61, right? Let us understand how it is happening. Dot product, right? So 5, 6. How it is presenting? Dot, right? Sorry. 5, 6. How the dot product calculation is going to happen, guys? It is going to be 5 into 5 plus 6 into 6. So it is going to be 25 plus 36, which is nothing but a 61. Same thing we got it here, right? 61. Where is it? Yeah, right? Now let us see the cross product. What I am getting. Guys, cross product, how it is getting presented. I have already told you everything. Just if you're not able to brush up your knowledge, just do it. When we are saying cross product, this is how it is getting presented. We have ijk. Ijk are nothing but your matrix. It's getting presented like this, right? They are your directions, right? So when we are saying I, this is j, and this is k. So this is your 3 dimensions, right? This is your plane. Whole thing is your plane, correct? 3D plane. Okay, now let us see. We have a vector A. How it is getting presented? Going to be 1, 2, 3. Now let us see another vector 4, 5, 6. How we are going to get the cross product of vector A and vector B. What we are getting? -3, 6 and -3. Now let us see how we will get. So when we are saying cross product, guys, we have to keep like this. We have to consider this. When we are considering this row, you need to consider this. How we will get? This is 6, right? Is going to be 2 cross 3. So 2 cross 6 like this, right? Cross, crisscross. Minus 5 into 3. Should be. Then again, what is the another one? Plus j into, when we are considering this, you should take this area and this area. So it should be 1 cross 6 minus 4 cross 3, isn't it? Similarly, we have k. So plus k. When we are considering this, you should take this area. So what it should be? 1 cross 5 minus 4 into. So what is the output I am getting? Minus I 12, okay, minus 3i plus is the output I am getting. 12 minus 12. Sorry, 6 minus 6. So minus 6 means it is going to be minus 6 8. And here 5 minus 12. So it's minus 5 minus, no, 5 minus 8. Sorry. That is going to be minus 3. Okay. So what is the vector we are going to get? Minus 3, 6, minus 3. Okay. Now let us see. Correct? We got the same thing here. Now we have something called matrix multiplication, and this is how you will present. So in short, we have at the rate, which will present your multiplication symbol when you are considering matrix multiplication, right? So yeah, you can see here, you will see the output. So let us see what are the matrix A present. So my matrix A contains, my matrix A contains 1, 2, 3, 4, and I am multiplying it with another again 1, 2, 3, 4. How my multiplication is going to happen, guys? Should be 1 into 1 plus 2 into 3. Like this. First like this. Second like this. Right? Now let us plus 2. It is not plus actually. We are going to see. Again, guys, when we are telling that if it is a 2 cross 2 matrix, 2 cross 2 matrix, my end product should always be 2 cross 2 matrix when I multiply. Should always be 2 cross 2. If it is, consider that if it is like this, 1, 2, 3. This is what, guys? 3 cross 1, right? 3 rows, 1 column into 1, 2. This is one what, guys? 1 cross 3. What is going to be my output here? The output or the end product should be 3 cross 3. So when you are calculating, it should be like this. The last two elements be considered and you should get output. Right? Now here let us see. So we got 1 here 1 plus 6, which is 7 we got. Then here 1 into 2, sorry 2 into 2 plus 2 into 4, got 8 plus 2, 12, right? Then we have got like this, and here like this. So 3 into 1 3 into 1 plus 4 into 3, correct? What we are getting? 3 plus 12, 15, right? Then we have something called 3 into 2, 4 into 4. 4 into 4. 4 into 4 plus 4 into 6 plus 6 plus 8. Right? 6 plus not 8. I think this is 4 into 4. Right? 6 plus 16, so 22. Let us see the output. Let us see the output what we got. Same thing we got, right? 7, 10, 15, 22. Similarly, we have something called determinant, guys, right? That determinant is again where we have used the determinant, we have used calculation of eigenvector, right? That is why it is important. So, how we are getting, we have, like I've already said, we have one module called LINALG, linear algebra. How you will load that module, guys? This is how you will load from NumPy. So when you are saying the top library, how you are doing, import NumPy as NP, right? Now we want to utilize some module of that NumPy. That means this is how you will present it. So you can say from NumPy import LINALG, and the same thing can be written like this, correct? Everything we can keep it with LIS here, right? So or you can say the nickname of that. So here when we are saying from NumPy import LINALG dot as LA, if we do like this, what we can do? And just simply replace it with LA dot determinant, and you should be able to get the things here, right? Now let us. We got the output, right? So what I'm saying, that whole module plus your library is bundled up in this LA, and I'm able to use the functionalities of that, right? Now let us see, we are taking determinant as a variable, and we are taking dot det is going to give you your determinant of that particular matrix. So what is the matrix we have taken, guys? We have taken 1, 2, 3, 4, right? Now let us see how we are going to be calculated. We have 1, 2, 3, 4. How my determinant getting calculated, guys? Like this, right? Even though it is a matrix, this is a symbol to calculate the determinant. How? Crisscross, just crisscross. 1 into 4 minus e into 2, which is nothing but your minus 2, correct? Now let us see. We got it minus 2, right? And one more thing, guys, when we are saying that, like, if you will not keep this format, like we have format, right? I have already explained you how we can use format while printing the output, right? This is how we are printing. And if we'll remove, let me just remove this, and we'll see. See, we got a very large, decimal, and it is of no use, right? If you'll see the precision we can take up to 3 or 4. We don't have to, like, when we are taking the precision, it is going to round up to the nearest value, and it is going to give you. So for that, what I did, I have taken dot 4f. So this is how you can change to the decimal till 4. Now I am able to get till 4th decimal, right? Now let us see. There are other operations, or there are other methods to get the 4th decimal thing, guys. So here you can see one example I have taken. I have taken of the precision, I think up to 8 or 9 it is there. Now it is, I have taken NP. Again, NumPy has that facility. NP.set print options. When we are talking about, see, everything is print, right? So remember in that sense, so you will be able to remember. Set print options. I am setting up the print options. So what? I am going to take till 4th precision. So precision equal to 4. And I am trying to print it. See how I got. It is rounded off till 4. Like what I can say, till fourth decimal, and you can see this whole area is getting rounded up to 6 because it is more than 5, right? When I'm saying 0.555, it is 0.5, more than 0.5. So it is going to be changed to 6, next decimal. Then we have something called, same thing we can be used with np.around. So you have taken the same thing I have taken here, and I have taken np.around. np.around means again it is to give you a rounded value. So that is, you can again remember the term set print options. np.around, I am rounding off. That is what around. How is, and again guys, do you have to remember all syntaxes? I'll tell you one simple way. When you'll hover over a mouse, right, on any of the functions, it's going to give you what exactly is the default keyword arguments present there. This is what, guys, I have already told you. This is your function definition, right? Function definition where you have like these are your keyword arguments, and this is how you can present your keyword arguments, right? Like here you can see def around, here a decimal is equal to 0, out equal to. So with that, I'm able to know, okay, my a is going to give you the first array, right? So nd array dot round. Okay, so I have inserted array. Then my default decimals, it is taking 0. So here I have taken 4. Like that, I am able to crack the things, right? You don't have to remember all syntaxes. Just need to remember what is the methods or what is the functions we are using. With that, you should be able to, even we have so much of libraries, inbuilt libraries NumPy has given. You can, anytime if you have some doubts, you can go and you can check there. Very useful. Now we have something called inversion of matrix. Again, see, right? Then how we are getting np dot, what I did, guys, I have taken, what's the lis name I have taken there on top, I have taken la. Now let me see, la, sorry. Now let me see, let me replace it to la and see what is the output I am getting. Right, it's working correct. Dot inv, inv means it is inverse of matrix. Then we have transpose, right? Again, transpose we have understood in a property, right, where array dot t, when we are using it, is transposing that array. Here again we can transpose the matrix. So this is how we can transpose the matrix, and this is the inbuilt method of transpose, sorry, of NumPy. And again you have to remember it, t, right? Everything it is giving you, right? This function definition. Then we have again eigenvalues and eigenvectors, and I have taken matrix A. Let me change it to LA. This is how you can get your eigenvalues. These are your eigenvalues, and for each, I have already shown you the calculation, guys. We got 2 eigenvalues here, and for each eigenvalue, what is the vector we are getting, correct? This is one vector for that eigenvalue, and this is another vector for this eigenvalue, right? Now let us see the rank. Matrix rank again is nothing but we are using like this, right? Matrix la dot matrix underscore rank. This is going to give you the rank of the matrix, right? So okay, let me see what is the matrix say. So my matrix A is nothing but 1, 2, 3. How my rank is getting calculated, guys? 2 rows, right? So 2 rows means it is 2 rank, right? Like that. Similarly, we have something called power, matrix power. Matrix power, what it is going to do? If you want a matrix to be of, like if you want to multiply a single matrix, in short you can say like that, if you want to multiply a single matrix into 3 times, so what is it? We want the power of 3 to that matrix, correct? This is how you will get it for the output. Basically, in short, what I'm trying to say here, we have 1, 2, 3, 4 into 1, 2, 1, 2, 3, 4 into 1, 2, 3, right? So, these two output will be input to this, and again you need to give a cross to the, or you can multiply this two. Like whatever the output you get from here, then you need to multiply with this two, right? So yeah, so we have understood most or the important aspects of linear algebra to NumPy, and I hope you guys can relate with the mathematics concept to this, and you can see how easy it is. With just one line we are able to get, but to know the calculation and to know the understanding why, what is vector, what is matrix, why we are converting them to array, because everything on the behind scene of AI or artificial intelligence is nothing but an array or a 1D vector, or you can say vector, right? Okay guys, that's it. Thank you. That is all guys for now. We will cover further NumPy libraries or modules in our upcoming videos. Till that time, see you. Have a great rest of the week. Start subscribing, like, share your comments, share your feedback. See you.